All right, hey everyone, welcome. Thanks for coming out. My name is Don Coleman, and I'm going to be talking about connecting phones to Arduino with Bluetooth and Cordova. So the basic problem here is that we have a device and have a phone, and I want to get them to talk to each other. There's a lot of different ways we can do this, so I'm going to talk about one way to do this. We're going to talk about Arduinos on the device side, and using Cordova or PhoneGap on the phone side, but a lot of this can be generally applicable to other things, like you could substitute a Raspberry Pi for the Arduino, or potentially other hardware. So we're going to be talking about Bluetooth to do this, and Bluetooth is originally designed as a wire replacement protocol, so for things like replacing your keyboard, your mouse, piping music to your speakers, stuff like that, and it works pretty well for that. There are some alternatives. We could be using Wi-Fi or just doing general TCP networking, which works great on phones because phones are almost always connected to the network. You can do that on the device side, but particularly with an Arduino, you don't have a lot of memory, you don't have a lot of power. So if you're going to be running an HTTP stack or other network stack, you're going to potentially be using up a lot of the space that could be used for other code. So there's some circumstances where your device is going to be plugged into a wall, you could do Wi-Fi. But there's other things where Bluetooth may be a better alternative. Then there's things like the mesh networking technologies, XB, Zigbee, Z-Wave, and then a bunch of 433 megahertz and other kind of random 2.4 gigahertz frequencies. Those are used a lot in getting small devices to connect to each other, and they can work well for certain circumstances. The problem is when going to a phone, that doesn't work because while some phones have Z-Wave, most other phones don't have any of those things. So if you're going to connect your devices to phones that way, you'll need some sort of bridge that's going to go between your mesh networking and your phone. So for some things, Bluetooth can be really good. Bluetooth means that you need to be close to it, though. It's 10 meters is the advertised strength for Bluetooth. There's some Bluetooth that'll do 30 meters, but pretty much you need to be within proximity of these devices to make them work, which can work good for some things, but if you're halfway across the world and want to monitor things, Bluetooth isn't going to be a good choice for you. So from the phone side, we're going to talk about Apache Cordova. And when I mention Cordova, sometimes I get a lot of blank stares. So the other name is PhoneGap. Apache Cordova is the open source version of PhoneGap. Originally, it started off as PhoneGap. When the source code was donated to Apache, they changed the name. So Adobe still distributes PhoneGap. There's other people that distribute Cordova under different names. So I'll use the terms PhoneGap and Cordova interchangeably. The thing to know about Cordova is that it's going to allow us to write native apps using HTML, JavaScript, CSS. So for the purpose of this talk, it's okay if you don't know Cordova. Really what we're going to be leveraging here is a JavaScript API to access the Bluetooth hardware and to be sending and receiving messages. So if you're going to run Cordova on your machine, the easiest way to do it is if you have Node.js installed, you can use the Node package manager to npm install Cordova, and it puts a set of command line tools on there. You also need, if you're doing Android, the Android development kit. If you're doing iOS, you need to be on a Mac and have Xcode and all those tools installed. If people are interested in that, I'm happy to talk about it later. I'm going to kind of gloss over that for now. There's really good documentation in getting started at the Cordova website. So really, what I said to remember now is that we're going to have JavaScript APIs to access Bluetooth, and we'll be able to do that from iOS and Android using the same APIs. Excuse me. So on the Arduino side, Arduinos are small microcontrollers. They're made for education, but people have hijacked them and do all sorts of things with them. They have really slow, crappy processors, so like 16 megahertz, but they're really good at doing I/O. So you can interact with hardware, you can read data in from hardware. They're really good at that. There's no operating system, so even though it's a super slow processor, your code can actually run pretty fast. And they're about $25, so it's like if you break them or you can have a bunch of them and put in places, it's really easy to get started with them. The other thing we're going to need is a Bluetooth radio. So there's a couple different flavors of doing this. Sometimes there's small breakout boards, like the ones on your left there. And so those small breakout boards, you'd wire them up and attach them to the Arduino. There's the other thing in the Arduino world called shields, which is over on the right-hand side. And shields basically plug into the pins on the Arduino, so it's really easy. You just stack them up, and then it gives you access to that hardware. So for some of the demonstrations today, we're going to use one of these breakout boards. And the way these breakout boards, the nice thing about them is they basically talk serial between the Bluetooth and the Arduino. So basically one transmits, the other receives, and the opposite of that there. So it's really easy to connect these things together, and you just have to really worry about 2 wires going in for the transmit and receive. So I showed arrows, but we're actually going to wire things up there. Once you have that, the Bluetooth radio and the Arduino can talk to each other. They can send data back and forth. We'll also wire some power up so we can have 5 volts powering it. And then once we have our phone in there, the radio will take care of doing everything between the phone and the Bluetooth radio on the Arduino side. And a lot of that becomes transparent to us and makes it really easy to get this code working. So when we're working with Android, we're going to use something called Serial Port Profile, which is a standard Bluetooth Classic spec that allows you to basically send serial data back and forth over Bluetooth, as if you had a wire connected. So we'll do serial over the Bluetooth, and then once it gets to the Bluetooth radio, we'll have a literal serial over a wire to the Arduino, and we'll be able to send messages back and forth. So when you go to program in Arduino, you use an Arduino IDE, which is a piece of Java software, so it runs on Mac, Linux, and Windows. And you basically have a printer cable or a USB cable that you can you plug one end into your computer and the other end into your Arduino. That powers it for development, and it also is how you send code back and forth. So we have one radio here, and this is it's an Arduino Uno, which is the most common one, and then I have this little Bluetooth radio on top of it. And we have this really short program here. I'll step through it because it's probably tough to read. But basically what this program is going to do is it's going to generate some data on the Arduino side, and we're going to receive that on the phone side. So it's not very useful as far as actually doing something, but as far as demonstrating how we send data across, it's a pretty good example. So the first thing we need to do is we're using something called software serial. And so what software serial does is a library that allows us to take 2 pins. I think I'm using pin 6 and pin 7, and that's what I'm wiring between the Arduino and the radio. So we include the header file for that, and then we create an instance where we just call it Bluetooth. Then I also have that counter variable, which is what we're just going to increment. So there's really 2 functions that get called in any Arduino sketch. They call Arduino programs sketches. So there's a setup, which gets called once when the machine boots or when you hit reset. It calls setup. So the first thing we do is serial begin. That's if we're thinking in JavaScript terms, that's like console log. We just need to call begin to get that set up. So that allows us, when we have the USB cable connected, we can debug and we can see what's going on. And then Bluetooth, we say Bluetooth begin. And so we're giving both of those a baud rate, and we're saying 9600 baud there. And then I just do a print ln, so I know that the program's running. It says Bluetooth counter, so we see something's going on. Once setup's executed, it goes into the loop. So what we do is we print to basically our log, we print the value of the counter, and then we tell the Bluetooth radio, hey, here's the value of the counter. We increment the counter, and we wait 1 second. And that'll happen forever. As long as this Arduino has power, that's going to keep going. So if I flip over to the Arduino IDE, I have that same program here. And should I have my port set up right? Okay. So once the program's in here, you just hit this upload button. It'll compile it, and it'll upload the sketch to the and you'll see any errors down the bottom if you have compile errors or if for some reason it can't communicate. We're programming in, it's a subset of C. You could actually write C or C++ and put pointers and do all kinds of horrible stuff in here, but you're discouraged from doing that. They really try to make it very easy to write code and hide all that complexity in any libraries you have. So once we've connected that, I can open the serial monitor. And when I connect the serial monitor to Arduino Uno, it resets the program. So it has that Bluetooth counter, and it's just going to keep counting there. And so we'll let that count while I start to talk about what we have to do on the phone side. So on the phone side, we could write native Android or iOS, and we could write all the Bluetooth stuff and do what we wanted. But I like to use PhoneGap or Apache Cordova to do a lot of stuff. So I wrote a plugin called Bluetooth Serial. I tried to mimic it a lot after the way the serial libraries work on Arduino, so it's really simple. You can write some data to it, you can read some data from it, and you don't have to worry about a lot of things. So if you're using Cordova and you're using the command line interface, you can use the plugin install command, and it'll download and install the plugin for you. And then this is going to be in our JavaScript code. Once we, the PhoneGap application starts up, we're going to hard code a MAC address, because I know the MAC address of this radio here, and we're going to say, hey, let's go connect to that radio, and we're going to use a command called connect. When we install the plugin, Bluetooth Serial is a global variable that gets, has all the commands for doing the serial, and the plugin puts that into the namespace. So the things we need to pass it, we got to give it a MAC address, we need to give it a success callback and a failure callback. So the success callback gets called when we connect, and the failure callback gets called when we disconnect. And the reason we do this is all of the Cordova APIs really work like that. You can pass some arguments in, but you're almost always passing in a success and a failure callback so that things can happen asynchronously and then your code can be notified about what's going on. So if we wanted to send data once we made that connection, we could say, just write hello Arduino, and once that connection is made, it's going to send that data over the wire, and we'll receive that on the Arduino side. If we want to receive data, we could do like a regular serial port. We could say, hey, are bytes available? And then if bytes are available, we can read data. And that works okay, but the problem is when you're doing Cordova and there's all these callbacks, it becomes kind of clunky because you got to say, hey, are bytes available? Wait for a callback, and you get this big triangle of doom there, like any good JavaScript code. So I was looking at that and said, hey, we can make this work to our advantage. Most of the time when data is coming from another system, it can be delimited some way. Maybe it's a line feed, maybe it's pipes, something like that. So we can subscribe to data and we can give it a delimiter, which is the line feed in this case, and then we can say on message and on failure. So then whenever the plugin sees a line feed, it's going to call my callback with on message with the data that it gives to it. So as long as my data, when I was sending it there before with the counter, I'm sending a line feed after every line. So here I can basically get a message every time that counter is incremented. All right, so now we can do another demo. So this is looking at the JavaScript part of the PhoneGap project. When you create a PhoneGap project, there's a www directory which contains basically an index.html, which is going to be the page that gets loaded when our application starts up. And then by convention, I put everything in index.js, which is our application where we're going to run our code. So this whole application is, I don't know, 27 lines of JavaScript and some HTML. Basically, important parts here, we have a counter div where we're going to take that value that comes in from the Arduino, and we're going to stuff it into the counter. Then we have a status div, so if things disconnect or whatever, I can just put a status message out there. Under the covers, Cordova is going to create an Android project for us. We can do Cordova platform add Android. It'll create the whole native project. We can do run, and it'll compile. It'll copy this code into the native project, and it'll launch on the phone. So I'll demonstrate that for this one. Just restart. I have a program that grabs the screen and displays what is being shown on my phone here, so I don't have to run it in an emulator because we're doing Bluetooth. So it works pretty good, except for there's going to be some latency on that. It's the frame rate is really slow, but you guys will get the idea of what's happening. So in my project, I do Cordova run, and that's going to compile the app. It installs it, and it launches it on my phone, and it disconnected it. Hang on, I think I had it running before, so let me try this. Nothing like live demos to make things interesting. Okay. Well, this wasn't my most exciting demo. We may come back to this if I have more time. Let me just try one more time to launch this and see if this cooperates. No, it's disconnecting right away. All right. Fortunately, I put a screenshot in my slides on this. So if we were connect, and like I said, I can come back and try this later. I probably have the wrong MAC address or something in there. We'll receive that data. So every time that callback is called, the data shows up there. And the nice thing about that, it was a very little code to do that. So now, one of the flaws of that, and maybe why my code wasn't working here, is that I might have had the wrong MAC address. Maybe I had the MAC address for a different radio. If I'm hard coding the MAC address for these codes, for this code, it works great for my hardware, but if I want to give you guys an app, that doesn't work quite as good. So there's another API called Bluetooth Serial List, and that will basically go out there and list any devices that our phone has been paired with. And so the good thing there is that you can show the user a list of stuff. You can let them choose which device they want to connect to, and then connect. So list gives us just a bunch of JSON objects back. And really the thing that we care about here is the MAC address. And we pass the MAC address into the connect function and then connect that device. So really the constraints on what we can connect to, it has to be something that supports serial port protocol from Android. And on Android, we only work with Bluetooth Classic right now. So it brings us to iOS. What about iOS? If you guys know that you can't really access Bluetooth Classic as a regular developer on iOS. There's a hardware program where people can make hardware that works with Bluetooth Classic, but you got to get approvals and sign NDAs and do all kinds of stuff. So the one nice thing about iOS is that they have support for Bluetooth Low Energy. So Bluetooth Low Energy is very different. You don't need to pair with Bluetooth Low Energy. You go out and you discover devices. And the other thing with Bluetooth Low Energy is that there's no spec for serial port protocol, so there's no way to stream data back and forth by default. So one of the nice things is that the hardware that I have does have serial-like services. So there's a couple companies, Red Bear Lab is one of them, and Adafruit has a radio too, where they basically have a serial-like protocol that has a transmit and a receive, so you can send data back and forth. So one of the things that, since it's not a standard, it means that my plugin only works with those particular radios right now. But as people come up with other radios that have these UART-like services, they can be added in. You basically need to add some UUIDs. So support can be added for other things, but right now, it only supports a few. So what these services are is, and these are from the point of view of the radio, because transmit and receive are always whoever's point of view you're at. So Bluetooth Low Energy works with characteristics. There's basically a big attribute table. And attributes can be read, they can be written, they can be require security, they can notify you when they change. So there's a receive characteristic, so from the phone we can write to that characteristic to write our data in. And there's a transmit characteristic where we can either read the value of that data, which is okay, but that means we need to keep polling the hardware. But there's something called notify. So we can subscribe to changes on that characteristic. So whenever any data changes on the radio, it will call back and let the Bluetooth Central role, which is going to be the phone in this case, it'll say, hey, this data changed, here's the value. So that's kind of a nicer thing there. So like I said before, there's no pairing though. So it works a little bit different. So instead of list is the same function, but it goes out and discovers devices. With Bluetooth Low Energy, devices advertise the services that they offer. So if they're in advertising mode, they're sending out these little packets every second or 2 seconds. It says, hey, this is my UUID. These are the services I offer. Here's how you can connect. So this filters and it knows what services it can connect to. So there's 2 different services. And it goes out and tries to find these devices. If it finds them, you get a similar callback like before. Instead of getting a MAC address, we get the UUIDs. So you'll notice there's some duplication where I have ID and UUID. Before I had ID and address. So the ID is common across both of those. So if you want to write code that just works, you can use the ID there. So once you have a MAC address and you say connect, things work pretty similar from that point on. One other thing to notice is that some devices will report a signal strength, or the RSSI, when they are advertising. Not all devices do this. You won't always get it with every packet. But the nice thing about that is you can then look and say, based on the signal strength, I can choose the device that's closest to me. I could choose the device that's farthest from me, things along those lines. So once you're connected, things are pretty much the same, with the caveat that Bluetooth, low energy, the characteristics are very small. They're basically 20 bytes of data going back and forth. So if you want to send large packages, you need to chunk that up into smaller bytes of data yourself. Yeah, so I said before, there's from Red Bear Lab and from Adafruit, I support those radios now. If anyone's interested in doing this as different hardware, I'd be happy to talk to you to see if we get supported for that too. So I have another demo. Hopefully this will work better than my last one. And I have this strip of lights here. It's 60 LEDs that can be controlled. And we want to control them from a phone. So since we're using a serial-like protocol, we can basically just send and receive data. We need to make up a way to control things. So what we're going to do here is we're going to send a literal C with 3 components for red, green, and blue color. So if we want to turn the lights blue, I'd send C00255 and then put a line feed on the end there. All right, so I'm going to do this demo, and then once the demo works, fingers crossed, I will kind of walk through the pieces on how everything worked. Okay, switch some wires around here. So this demo here, I'm using a Bluetooth low energy radio, and I'm going to use an iPod. Well, if all works, we should mirror the screen here with AirPlay. So right here, I'm listing the devices that I found. The name Biscuit is just what they put in the hardware of this, so it has kind of a funny name. So usually on this phone, it takes about 3 times to connect. My other phone works a little bit better. We'll give this one more try, and then I have a backup phone here. I must have pissed the demo gods off. This usually works. There we go. Okay, I got my other phone to connect, so let me see if I can do AirPlay on this one. All right. Just put these over each other so we can ignore the other one. So now that we're connected, I have these 3 sliders here. This interface is built all with HTML. Each of the sliders sends a red, green, and blue value. So if I crank the blue slider up, the lights turn blue, and we're sending, you can see the value there. I'm sending 00157. We can crank some red in there. And basically really easily control these lights. So normally I'd pass my phone around, but I don't feel comfortable passing my iPhone around. I'd pass the so afterwards, if you guys want to check this out, you can come up here and check this out. Otherwise, with Phil, he'd probably be tweeting from my phone if I sent it. So let's look at kind of what this code is doing here. So for each of those sliders, I have a on-change event. And I basically register one handler for all those. Whenever any one slider changes, I have a function where it goes out and gets the color from all of those, because this is 3 sliders there. Then we just set the inner text so you can see that value there, the 00255. And I also set a preview color just using setting the background color there. So that works good on the brighter colors. When you're down in the dimmer colors, it doesn't match as good, but at least gives you a little bit of an idea. And then I say send to Arduino, where I send that color value to Arduino. So on the Arduino side, all that I have to do is basically say write. I give it that C, because that's what command's expecting. The value, 00255, and then the line feed. And then it goes over the wire, and it handles everything magically. So now we want to look at what is the Arduino side doing? So, actually, I'll just step through my slides here. All this code is online in the sample directory of the plugin. This code and the counter code is available. So once again, we set up the Bluetooth like we did before. We have a couple pins. The Bluetooth looks essentially the same whether I'm using the Bluetooth Low Energy or I'm using the Bluetooth Classic. Since we have the serial connection between the breakout board and the Arduino, it doesn't really matter. So I set up software serial, and then in here I do something where, kind of similar to where I did subscribe and I was waiting for a line feed. In here we use a command called find, which basically will read data and throw everything away until it finds that C, and then it stops. Once it finds that C, I can parse the next 3 integers to get my color value. And then I have another function called show color, which basically these light strip came with an API where I can set the color to anything and show whatever color you have on there. So with very little code, in fact, the code the actual code prints out the values of what came in. The code to print out the values is actually more code than to do the real work. So we have 2 examples there. The first example was sending from the Arduino to the phone. This example goes from the phone to the Arduino. Most apps will really probably do both of those. I have a project for a Bluetooth Low Energy lock, where it's basically a solenoid-based lock and a Bluetooth Low Energy radio and an iPhone app. There's a link from the slides here. A couple weeks ago on the Make Magazine blog, it steps you through how to do this. All the code is online, and there's a little video that shows it working there. But basically, you enter a PIN code on your phone, it sends it over Bluetooth, and it will unlock the lock. So that right there, we were using data going one way to unlock it, and then statuses were coming back. So just to recap, the Bluetooth serial plugin, it uses Bluetooth Classic for Android. It uses low energy for iOS. Theoretically, you could do low energy on the newer Android devices, but it's not implemented in the plugin right now. We could either list devices that are paired on Bluetooth Classic or discover devices on Bluetooth Low Energy. Then once we connect, we can use write to send data, and we can subscribe to read data. And so it makes it nice and straightforward, and it really hides a lot of the complexity of the Bluetooth underneath the covers for that. And so I think that works pretty well. There's a lot of people using the plugin. I actually got a phone call the other day from someone. They wanted a different plugin written, and I'm like, well, hey, how'd you find out about me? And they're like, oh, we're using your plugin in this commercial product that's out in the App Store and stuff like that. So I'm like, okay, good. This is really working for real people here. So that's one way you can do Bluetooth with just regular Arduino. There's some newer hardware coming out. There's been a lot of Kickstarters and other things like that where people are coming out with special purpose Bluetooth and Arduino combined together. A lot of those the Kickstarters have been funded, but they haven't necessarily shipped yet. They'll be coming out hopefully soon. This one, Arduino, is one that's actually available, and they're cool. I like them because they're really, really tiny. And on that chip right there is an ARM-based Arduino-compatible CPU and a Bluetooth radio built in that package. And if you look on here, I can power it from a coin cell battery. So I have another plugin which works similar to the Bluetooth serial plugin, but this one's for the Arduino. Now, Arduino is only Bluetooth Low Energy, and so I tried to make this one a little more Bluetooth Low Energy-like, but there's still a lot of things that work serial-like. There's one service on this radio where it's basically a serial-like service where it has a transmit and a receive. So when you want to find Bluetooth devices that are out there, From the phone, you basically start scanning. And you scan, you say, hey, you start listening for who's out there. These things are broadcasting all the time, but when your device goes into scan mode, that's when it finds them. Now, you could scan all the time if you don't care about your battery. If you're scanning, it really drains battery. So you really try to start scanning, find some devices, shut scanning down. And I got sick of writing that code over and over again. So I just said, hey, we can pass in a number of seconds here, and we'll just discover and find what we can. So the success and failure callbacks work very similar to the other plugin, where as devices are found, we'll get the success callback. So it'll say, hey, we found this Arduino, here's our UUID. There's an Arduino specific thing where they let you put an advertising thing in there so you can differentiate. This device is doing one thing, this other device is doing another thing. We also get the signal strength if we want to try to do some distance stuff from there. Instead of getting a list back, though, every time a device is discovered, the success callback gets called again and again while we're discovering. So it's my responsibility on the app side to keep track of those devices and make sure I'm not showing duplicates and things like that. Once we have a UUID, we can connect to it. We pass the UUID in. We have a success and a failure. So similar, we can write data to it. There is a success and a failure callback to that. Most of the time, I just skip those because you don't usually care. Hopefully, the data goes across. If something happens, you will actually get a failure, but you're usually getting a disconnect call before there's a failure. So instead of subscribing, we have something called on data. One of the nice things about Bluetooth Low Energy is that some characteristics can be notifiable. So when the data changes on this radio, the phone gets notified because we've subscribed to it. So since the Arduino has one service, I subscribe and do all that when you connect. And so that whenever it changes, it calls this callback. So if we care about that, we just implement on data, and we'll get data coming back into us. So one of the examples that comes with our Arduino is they have an iPhone app that has, there's a temperature sensor built into here, temperature and humidity. And so they basically just show that. So I'm doing the same thing here where we get that data in. It comes back as an array buffer, so we need to know a little bit about the data. So we need to cast that to an array and then grab the first value out and then convert that to Fahrenheit so I can show it. So I have yet another demo. So get this going, turn this on, let's start advertising. Oh, you know what? I put this in airplane mode. I wonder if it turns Bluetooth off. That's why my other demo didn't work, because Bluetooth is off in airplane mode. Oh man, I'm going to be another demo failing here. This is Bluetooth Low Energy. So I have KitKat on here. So if you have Android 4.3, you can run Bluetooth Low Energy, kind of. It's pretty buggy. It's buggy in Android 4.4 too, but it's a lot better. There we go. So here I'm giving a list of things that I discovered. So if I click on this, it's going to show, and I'll have some temperature data on there. There's a little bit of lag now. It's actually reporting higher than the temperature in the room because it's on the chip, so some of the heat's in there. But then if I hold on to this, the temperature should increase. Or I've been holding on to it, I already got it. There we go. So we're actually getting live data every time this changes. And that's really simple. There's just very small amount of code. If you go in the Arduino plug-in there, you can look at it. It's less than 100 lines of code to be able to send data back and forth and display it on the screen. I chose to do this one here because you don't need a lot of extra stuff attached onto here, and it mimics some of the demos, the native demos that come with the hardware itself. So I'm going to screenshot in case things fail. So to recap, the Arduino plugin, we got Bluetooth Low Energy for iOS and Android, so you need newer Android if you're going to do that. It works on almost any iOS devices. iPhone 4S and above have Bluetooth Low Energy. It discovers devices. As devices are discovered, it does that callback, so there's a limited time to do that. Once you connect to a peripheral, you have the same sort of thing. You're going to connect, you're going to write to send data, but then instead of subscribe, well, there will be a subscribe, but it's called on data. So you call on data, give it your callback, and that callback will get called anytime data is there. So that's kind of how things are working today with what I've done so far with the Bluetooth and the Arduino, and it works pretty well. I think there's definitely some limitations that it's serial. One of the things about doing most of the serial communication is that you're kind of responsible for figuring out, hey, how is this data going back and forth? And that's okay as long as you control both ends of the pipe. I think some of the more exciting stuff is happening with Bluetooth Low Energy, and I haven't written a PhoneGet plugin to do this, but just writing native code to do it, where you can connect to different devices. Since you can go out and you can discover devices, and then you can start to interrogate the devices and see, hey, what services and what characteristics are available, and then start to integrate with those. Now, sometimes you're lucky and manufacturers will actually publish the specs for what they have. There's a Smart Robotics has a light bulb, and you can control that, and there's, you can turn it on, off, you can dim it, you can do a lot of things. And some of their specs they actually publish, so you can easily write an app to go against that or kind of bring it in and automate it with other things. They have some other things which aren't. So some of the other devices, if there's an app, you got to get in, you got to try to reverse engineer what's going on and see, hey, what are these characteristics? What do they care about? What do I need to do? But I think that that's going to be a lot of the thing. It's one thing to stuff that I'm building and having things work together, but it's more, how can I take and interact with a lot of these other devices? So since Android's supporting Bluetooth Low Energy, that's great. If you go and look in the Android SDK, they put all the Bluetooth Classic examples under a legacy folder now. So I think that they're really trying to go that way. And once again, since Apple's only been doing the Bluetooth Low Energy, they really kind of helped set the market for that. There is one plugin out there, Bluetooth LE. There's a guy, Rand Dusting, is writing it. It's still kind of immature, but there's people using it, and so they're kind of working through what the API should look like and how that should work. So if you're interested in doing some of these Bluetooth Low Energy things directly, you can look at his plugin and check that out. And then here's a bunch of links. These slides are all online. You can see the GitHub URL up there, and you can follow through on there. So I guess now I'll open this up. Thank you guys very much. And if you guys have any questions, I'll be happy to do my best to answer them.
Two quick questions. One, you mentioned that there's no pairing. Is there no security with Bluetooth LE devices?
Yeah, so I kind of glossed over that. In Bluetooth Low Energy, there's the default method is kind of just works, where you can go out and you can discover devices, and then you can just connect and read and write to these characteristics. There is something where you can do bonding, and you can set security on the characteristics, so you may have to do a pairing. So some devices will have some things that you can read and write, and then other things where you have to pair to do that. All the data going back and forth should be encrypted, but that encryption has been broken, so there's security-ish stuff on it, but I think that it's, I'm still trying to work through all the details on that.
And just to follow up to that, there are people, I think it's like Schlag or something that has like a Kivo product. I think it's similar, or probably does something like Bluetooth LE when you, I think it's something called like leash, just like profile or something like that. Do you support that? So that, let's say for your lot, you just walked up to, you got in range or got really close with RSSI, it would automatically?
Yeah, no, my demo didn't do that. And yeah, they probably use some sort of bonding where you bonded your device and you put in a pin code, and then also proximity. One thing I didn't talk about this was iBeacons, and don't really do anything with iBeacons with these plugins, but the big thing with iBeacon is kind of advertise only, and then so you can have something listing for that, and when it gets near a specific beacon, the app could then do something. It could see that, hey, I'm near the lock at home, and then so now I know that I need to go and pair and connect to it. So that may be what they're doing. I'm just kind of spitballing there since I haven't actually looked at their locks, waiting for the prices to come down on that.
I think you just touched on a good follow-up question, which was the iBeacons. Do you have plans to support the ability for the app to wake up in the background when it reaches a certain beacon and do an event?
Yeah, I think that I was thinking about how to implement that, and I think that's going to be a different plugin. There'll be an iBeacon specific plugin. I still need to write a little bit more native code to make sure I fully understand the best way to make that work. I've done some things that wake up when you get near things, but if you're, especially with the iPhone, if the screen is powered on, even if it's locked, it'll find those beacons relatively quickly. But if it's powered off and you want something to happen quickly, it doesn't necessarily happen. You may enter a kind of a geofence area with these beacons, but it could take sometimes 4 minutes for that to show up. And until I can kind of work through some of those things, the plugin wouldn't be very useful. So.
I noticed that you weren't surprised when it didn't connect the first time. In terms of reliability of connecting both Bluetooth Classic or low energy, what's your experience there? And I've seen it with other products that it's challenging at times.
Yeah, most of the time Classic almost always connects, so I was surprised on that. But having Bluetooth turned off and my code not telling me that, so that was a programming error there. With this particular iPod Touch here, I don't know if it's a version of iOS or whatever I have on here. It doesn't like to connect, whereas my phone almost always connects to the Bluetooth Low Energy. So it's finicky, but I haven't really found a pattern with that. I don't know if it's versions of the library. Sometimes I switch these radios out for different ones of the same models, and other ones will connect better. I've been in places where there's lots of different traffic, and I'm not sure how much that affects it. But Bluetooth is supposed to be really tolerant of lots of other Bluetooth devices and stuff around, but yeah, so it's unknown right now.
Good with music devices pairing to my Bluetooth in my car, etc.
Right.
Once you're connected, do you see is that more reliable at that point?
Yeah, it seems to be pretty good as far as the connection. Once it's connected, as long as you don't go out of range, if you go too far, it'll break that. But yeah, for the most part, as long as they have consistent power. Any of the battery-powered things, once the power starts getting low on the battery-powered Arduino stuff, sometimes the signal will tend to cut out too. This one here, the code isn't optimized at all. As long as it's just advertising and doing stuff, a couple weeks, I think. If you're trying to run power LEDs and stuff like that, you only get like a day out of it. A lot of the Bluetooth low energy devices have a goal of running 2 years on a coin cell battery, and they do that. You got to have really efficient code on that, where it's basically advertising and it goes back to sleep. So as long as you're writing your code so it's not keeping the CPU powered on all the time, you can get some pretty good battery life out of it.
We touched on battery life and advertising going back to sleep. If you're not advertising but are still, I guess, connectable, and is that something that you can sit at and live for a long period of time, let's say like a year?
Yeah, I mean, so devices can be discoverable and connectable, and so they can just be one or the other. Typically, a lot of these devices are always advertising, always connectable. Some will have a button more like Bluetooth Classic, where you got to push a button so it starts advertising for pairing. Honest answer, I really don't know on that. Most of the time, just when I'm running the Arduino code, if you're not sleeping the processor and doing stuff, I run the batteries down. I need to learn more about how all that hardware works to do it. But when it gets to that point, I basically try to talk to the hardware guys and say, okay, hey, here's what I want to do, and can you make this work better so I'm not going to trash everything?
Can we tell how far the Bluetooth device is using some? Is there any JavaScript API to tell that?
Yeah, right now there's known. I don't know of a JavaScript API to tell how far away it is. I mean, some of the code I have, it's giving you the advertising signal strength there, so you could look at that. If you're using iOS and you're writing native code, they basically break it down. A lot of the low energy stuff, when you want to know the distance as far as beacons and stuff, is not under core Bluetooth, it's under core location. And you basically say, hey, I want to look for these beacons and I want to know where they are. and you'll get a call back, and it'll either be immediate, like you're right on top of it, near, there's some other one, and then far away where it can't find it, so it's breaking it down. There's other people, Texas Instruments has a sensor tag kit, and they have some demos where they actually try to look at, see, hey, am I next to this sensor, am I away from it? A lot of these things, or Estimote's another one where they have it and you can calibrate it. You're supposed to put it a meter away, it looks at the signal strength, and then it can estimate the distance. And if there's nothing in between, that kind of works. But as soon as you start putting walls and other interference and stuff, at least the estimates I've seen are pretty bad. So if you want precise measurements, I don't think it works good, but I think if you want to know about how far away things are, you can make that work. All right. Well, thank you guys very much. If you want to check out the demos, come up here.